Welcome to this class, and in this tutorial we are going to cover MAT2100 tutorial sheet 6, which is on vector analysis. To begin with, we're going to solve this question, and it reads: given that A, which is a vector A is equal to 3i plus 2j minus 4k, and B is equal to 3i, then I have 2j plus 7k. We're told that find cos theta, where theta is the angle between the two vectors. So what do we have to do? So for this question, you ought to recall that cos theta of two vectors aligned like this is just equal to the cross product of those vectors, the dot product of those vectors, then the magnitude of the vector A and the magnitude of the vector B. So this here is the formula that we're going to use in order to find and compute our question here. So what do I do from here? All right, so let's first find the dot product. So I can write my vectors in the form where I say 3, which is the ith component, then I have 2, then I have -4, then finding the dot product, of course, of 3, -2, and 7, like that. Okay, so from here, we always handle vector in a component wise. So I'm going to multiply the jth entry, the ith versus the ith component with the ith component of the other vector, and so the jth and the kth. So here what we're going to do, since it's a dot product, when we multiply, then we add. So we say 3 by 3. So 3 multiplied by 3 gives us a 9. Then here I'll be adding. So plus, then 2 multiplied by -2 gives us -4. Then plus -4 multiplied by 7, that just gives us -28. So I have -28 here. So this just gives me 9 minus 4. Then this will be minus 28. So what do I get from here? So when I subtract these two, I see, okay, there, this just gives me -23. So I just have -23. Okay, so what do I do next? So next we find now the magnitude. So I have to find the magnitude of A. So this modulus in this case, or in this part of the course, means the magnitude. And this is just defined as the square root of every, then you square every component of that vector. So we're going to square, so we have A, which is there's 3, there's 2, and there's 4. So I square everything there. So I'll square 3, then I'm adding square 2, I add that, then I'm going to square -4 squared, then I add there. So what do I get here? So when I square this, I just have the first one gives me 9 plus, then the other one gives me 4, then the other one gives me 16. Okay, so when I add everything here, so I add 2, that's 20, plus that gives me 29. So I get 29. So I get the square root of 29. I do the same for B. So I say modulus of B is going to be equal to the square root. Then I square every component of that vector. So I get 3 squared plus -2 squared. Then I have a plus 7 squared here. So what do I get? Then I just get 9 plus a 4. Then I have this is plus 49. So when I add everything together, sum up everything, I just have this here will give me 58. When I add 9 plus the 49, so 58 plus 2, that gives me just root of 62. So I get root 62. Then from here now, I can just replace in my formula that is there. And remember, they're just telling us to find cos of what? Of theta. So replacing there, what do I get? So when I replace everything there, I just get that cos theta is going to be, so the dot product, I'd find the dot product to be negative 23. So the dot product was negative 23. Then I have there the magnitude 29 of A, then the other one 60 what? 62. So now here, this just means that I can multiply, keep the root, then multiply what's under there. So I multiply 29 by 62. Okay, then from here, what is my answer? So when I multiply those two, you have to get 1,770 and 98. So 62 by 29. By 29. Okay, gives me the same 1,000. So I just have that this here is just going to be equal to cos theta is going to be equal to negative 23 over root of 1,798. And here is my what is my answer for the first one. All right, so moving on to the next question. The next question says find the magnitude and direction cosine of each of the vectors. So we want to find the magnitude and cosine of direction of what of each of the vectors. So first of all, the first one, we have A here, and we have the vector V equal to 2I plus 5J minus 7K. So here, to find the magnitude, we just from doing this, so we're saying magnitude, we just equal to the square root, then I square each and every component here. So I'll just have 2 squared plus 5 squared, then minus 7 squared there. So when I square everything here, I just end up with 4 there plus 25, then, oh, this is plus. Okay, so let's do this. So this is plus, then negative 7 there. So now when I square everything here, just going to get 4 plus, then that gives me 49. So adding everything, you have 49 plus 4, then plus 25. Okay, so that gives you 78. So that gives you 78. Then now you have root of what? Root of 78 as your magnitude there. So we found the magnitude. Now how do we find the direction cosines? So direction cosine just means that I am going to divide my magnitude into every component of my vector. So I'm going to call the first one. So I'll call them to say, I'll have it in terms of cos alpha, then I say cos beta, then I say cos gamma, like this. So this is how it's going to be. But then I'm saying I am dividing. So to get cos alpha, I'm going to divide my magnitude into what the first component of my vector, which is 2. So I'll say 2 over 78, like that. Then for the next one, which is cos beta, I'm just going to get the second one, 5, then I divide by my magnitude again, 78. I do the same for the next one, which is gamma. Then I'm just going to get as negative 7 over root of 78, like that. So now my final answer is going to look something. So this is my magnitude. So I found my magnitude. First of all, my magnitude 78, found my magnitude. Then my direction cosine is just going to be 2. Then I write there, that is root what? Root 78. Then I have 5 over root 78 there. Then I have negative 7 root 78, like that. So that's my direction vector. Okay, let's do the next one. So the next one, we just follow the same procedure. And we say we first find the magnitude. So I have 1 there, so 1 squared plus 7 squared plus negative 7 squared there. Then this just gives me 1 plus 49 plus 49 like that. Okay, so that plus 49 plus that, then this here just gives me this gives me 99. So I just get root 99. Of course, I can write my root 99 as this can be 9 by 11, and this just gives me 3 root 11 like that. So this is my magnitude here. Then I do the same. So I'm going to divide this into each component of my vector to get those direction cosines. So the one for alpha, meaning is going to be 1, since there's I there, which just means it's 1, 3 over root 11. Then 1 for beta is 7 over, so 3 root 11. Then I have cosine gamma, which is negative 7 over 3 root 11, like that. And of course, I can just write that in a very nice way, where I just say my direction cosine, I write them as 1 over 3 root 11, comma, then 7 over 3 root 11, then I have negative 7 over 3 root 11, like that. So this here ends up to be my direction cosine. Okay, let's move on to the next question. So the next question then says, let u equal to that, v that, w that, and x that. So now they're telling us to find first of all, so this is u. So A says find u, this is dot product of w minus v dot product of what? Of x. So let's first find the dot product of u, w. So uw dot product of uw is just gonna be, so I get my u, and my u is 2, comma, negative 3, comma, 4. Then I do the dot product here. Then the dot product is just of w, that is 1, negative 7. Then I have my 3 there. So this here is my dot product, which I am supposed to find. So now, what do I get? So I multiply component wise. So the 2 multiplied by the 1, 2 multiplied by 1, that gives me 2. Then plus negative 3 multiplied by negative 7, that gives me 21, positive 21. Okay, so I get positive 21 there. Then I have plus, then my 4 multiplied by that 3 gives me 12. Then adding all these, summing everything up, I just get that 12 plus 21 plus 2, this gives me 35. So I get that my dot product there is 35. I do the same for the other one, which is v dot product of v and x. So my v, what is my v? So my v is just negative 2. Then I have minus 3. Then I have that is plus, no, that's a 5. So I get a 5 there, like that. Then dot product, then I say my x is just 3. Then I have my x is 3, 4, and 5. Okay, so doing the dot product there, I'm just going to have that, so I can multiply the first one, negative 2 and 6 and 3 gives me negative 6. Then I'll add, so plus, but then when I multiply negative 3 by what gives me negative 12. Then I multiply my 5 by 5 gives me, that is 25. Adding everything here, I just get that is going to be, it's gonna be what, 7? So 25 minus 6 minus 12, that gives me 7. So I get 7 there. So this here is what is my dot product for v and x. But then to finish up my question, because my question is u dot product of x minus v dot product of x, w, I mean u dot product of w here, then vx, like that. So this is just going to be 35 minus 7, and 35 minus 7 just gives me 28, and just like that I find the first one there. Okay, so the next one talks about the projection. So next one, we have to find the projection. So what this here is just the projection, finding the projection of U along V. Projection of U along V. Projection of U along my V. So here this is given by the formula. So first the dot product. So dot product of U and V, dot product of U and V, then dividing by whatever vector I'm going along. And in this case, it is what? It is V. So I have to find this vector, the magnitude of this vector, then I square it like that. So then multiplying by what? By the same vector I'm going along, which is V. So this here is the formula that I'm gonna use. So now what do I get from here? So dot product of U and V. So there's U and V there. Let's find the dot product first. U dot product of V. And this is just going to be 2 there, -3. Then I have 4. Then, of course, dot product. And then I'm saying V, -2, -3, and 5, like that. So this gives me, I multiply the 2 and the -2 gives me -4. I'll be adding, because -3 multiplied by -3, that gives me +9. So plus, then 4 multiplied by the 5 gives me the 20 there. So this is what I get. Then this just gives me 25. So my dot product is 20 what? 25. Now I need to find the magnitude. So I need to find the magnitude of what? Of V. So magnitude of V given like this is just square root of whatever I'm going towards to the component of that vector V. But then look, I'm squaring. So if I'm squaring a square root here, meaning the square root is going to go, and I just remain with saying that the magnitude squared of the vector V is just going to be those components squared. So I get -2 squared, then plus -3 squared, then I have plus 5 squared there. Then this gives me 4 plus 9 and plus 25. So adding everything, 25 plus 4 plus 9, and that there gives me 38. So this here is gonna give me 38. So I have found what I have. I already have V, of course. So this here, I write it here, 38 as K, like that. Now let me replace here to get my projection. So when I replace here, I just have that the dot product there. Dot product is just 25. Found that. Then over that is over 30. That is over 38. Then multiplying the vector V is just -2 I minus 3j, like that, then plus 5k. Okay, so this is what I get. And of course, if you want, you can multiply each and every component by this, but then if you desire, you can just end here. So this is the okay. So this here is the projection of V, U along V. So now let's do the opposite. The opposite is the projection of V along U. V along U. So, okay, so projection of V along what? Along U. So, what do I get when I do that that calculation there? So, here I'm going to have the dot product again. So U and V. Then I'm saying U squared this time because it's along U. So this will be U squared then multiplied by U. So let me get the dot product first. So UV, like that. So what is this going to be? So my U is 2, -3, 4. Then my V is -2. Okay, this is not This is not gonna change, so it's just the same. So it's going to give us 25 as we found. So earlier we found this is 25, but then we can find u squared, and u squared, the components of u, I just square them. So 2 squared, and that's plus negative 3 squared plus the 4 squared. I end up with 4 plus 9 plus 16. So 4 plus 9 and plus 16. This just gives me 29, like that. All right, so this is what I get. Then just going to say the dot product is what? 25 over 29, and multiplied by the vector u, that is 2i, then minus 3j, then I have plus 4k, like that. So this here is my projection. All right, so the next one, similar question, but now it's x along w, x along w. So projection of x along w. So again, dot product of x and w. Yes, there, x and w. So then divided by the one you're going along, which is just w, then I square it and w, like that. So dot product, so I get the dot product as x. Dot product of w is just my x is 3, 4, 5, w is like 1, -7, and 3. This gives me, multiply 3 by 1 gives me 3, then plus, but it will be minus because of this negative sign. So 4 multiplied by that gives me -28. Then 5 by 3 gives me 15. So I'm just going to have 3 plus 15 gives me 18, of course, then minus 28. This gives me -10. So I get my dot product to be -10. Then w squared, the components of w, just square them. So I get 1 squared is just, okay, it's gonna be 1, let me write it still, plus -7 squared, then plus 3 squared. So this gives me 1 plus 49, then plus 9. So this is going to be 59. So I get 59. So replacing in there, I'm just going to have that this is going to be, the dot product is -10 over that factor there, that's just 49. Then w is just I minus 7j, then plus 3k, like that. All right, then this is my projection there. Okay, for the next question. Next question, they're telling us to find the equation, the vector equation, parametric equation, and symmetric equation of the points joining. So there's that point and that point there. Okay, so what do I do? So I have this point for -7, 7. Then I have q 2, 3, then -1. Of course, you can graph this, or you could write this on a graph, but then it's not really our concern right now. But just presume maybe there's this point and that point, this is connecting, and this is the okay, not really like this, but let's say this is our, if we say this is our origin, we have that vector, maybe this is p, that is q, like q, then you have this joining like this. So now they're telling us to find the vector equation of that. So how do we do that? So to find the vector equation here, first of all, so you always want to note that the equation or the vector equation is given by r. So let's say r equal to r naught, then plus td. So the r naught is just your starting point, or the point which you pick, whatever point you're gonna pick on of that vector, or yes, so whatever point you pick. So, and in this case, starting point where we are is the vector that we're gonna use as the standard of which we'll be picking. So d is just the direction vector, and the direction vector is just determined by, so d is going to be, so you get the first So your starting point, you have your final. So let me say final minus your initial. So this is how we're going to calculate D. So we already have R naught in this case, which is P. Then let's find our direction. So our direction is just going to be me subtracting my final, that is, she's going to be Q in this case, -2, since we're going, it's joining. So presume we're going P to Q, such that our initial point we start from P, then we go into Q. So this is like this, 3, then -1 minus, okay, my initial is 4, -3, then 7, like that. So this is what I get. Then computing this, I'm going to have this -4 gives me -2. That -4 gives me -2. Then 3 minus 3, this becomes +6. Then I have this is 1 here. So -3 minus 7, this gives me -8. So this is here, this will be my direction vector. So what does this mean? This then means that my vector equation, which is just R, is going to be the initial point, which is our starting point vector is just 4, -3, and what, and 7, like that, plus T. Then we put now the direction, what, our direction vector there, which we're just finding, and this here is -2, 6, and -8, like that. So to get this, I'm just going to have that this is going to be equal to, so I have 4, -3, 7, multiplying the T, I just get -2T here, 6T, then -8T. So I can now add, of course, component wise, that plus that, this gives me 4. So I have 4 minus, so okay, so so you have this where we're saying each and every part of it, there's this part where there's the I and the J, but then so when you add R, so you get 4 minus 2T, like this. Then the next one is -3 plus 6T. Then I have the last one as 7 minus 8T. So these here are my vector equation. I can now write it in terms of the components I, J, and K. So 8T, then this is the ith component, plus, then that is -3 plus 6T, J, like that. Then of course plus 7 minus 8T, the K, like that. All right, so this is my vector equation. So I found my vector equation, and from my vector equation, that's where I'm going to get my other parts of it, which is my parametric and symmetric equation. So parametric equation is you noticing that this is just written as the component of x, y, and what, and z, x, y, and z, and writing it out like that. So now this means this is going to be x equal to this will be x equal to 4 minus 2t. Then I have y equal to, so you leave out the j because you're not writing the vector, but it's just a parametric equation. So this will be -3 plus 6t. Then you have your z to be equal to, so your z is equal to 7 minus 8t. So this here is your parametric what equation? Vector equation down there, parametric equation up there. So now what do I do next? Next, what we have to find here is the symmetric equation. So to find the symmetric equation, what you're going to do is make t the subject in each case. So making t the subject, I have x minus 4, then of course -2t divided by -2t. I just have t is equal to x minus 4 over -2t. Okay, then I have the other one, you have y minus, oh, that would be +3, then divided by what? By 6. So this is t equal to this. Then the other one, you just get that I'll have 7 minus, z minus 7 t, this of course divided by -8. So this here like this, then I write it all in one, equating, since they are all t's, so meaning I can write it as -47 x minus 2 over t is equal to y plus 3, 6, and this is equal to 7 minus z minus 7 and divided by -8. So this here is what I call my symmetric equation. So this here is the symmetric equation. Then there, this one here on top, this one here is the parametric, and the one we wrote earlier was the vector equation. Okay, so let's look at the next one. Right, so the next one says find a vector parametric symmetric equation of the line containing the point that and is parallel to that. Okay, so find a vector. So we need to find the vector equation, the parametric equation. So I need to find the vector equation, parametric equation, symmetric equation of the line containing, they've given us a point, initial point or a point on that line. Then they're telling us it's parallel to another line, and this is the other line here. So now, one thing that we must know about lines that are parallel, lines that are parallel are going in the same direction, meaning they have the same the same direction vector. So lines that are parallel have the same direction vector. And when you observe, as we had written there, the equation. So this equation here is given as a symmetric equation. So always in a symmetric equation, the numbers that are down here are the direction numbers. So the direction numbers, meaning will make my direction vector. So meaning for the first one, it's for the for the ith component. So that's ij, then plus I2i, then I have the one which follows is 1, so I get j just like that, then minus 3, the k. So this is my direction vector. So this is the direction vector for this line and the line which I have to find now. But I've been given already a point on my line. So according to how the formula is, or we say R B, which is my vector equation, or my vector equation, then I'm saying R naught, then plus T D, and D I found that is my direction. My R naught is here already given because I have that point there. So this is gonna be 3, 1, then -2, then plus T, then I have -2, then I have that to be 1, and then 3 like that, -3 like that. Okay, so this here then gives me so 3 plus it, -2, so 3 minus 2t there. This is for I. Then I have 1 plus t, because it's t minus 1. So I am going to have 1. So this will be plus 1. This will be plus 1 plus t, like that. So this is going to be for the j. Then now the last one here is okay, I multiply that by that, then I just get this is going to be plus -2 minus 3t, then the k, like that. So this here is my vector equation. To get the parametric equation, I notice that this is just written as x, y, and z. So I just equate to say my parametric equation is just x equal to 3 -2t, then my y is 1 plus t, then my z is -2 minus 3t. So there is my parametric equation. Next, to get the symmetric equation, I just make t the subject. Then I'm just going to have that is going to be the first one, x minus 3 divided by -2. So t will be equal to this. Then we're saying this, of course, is equal to, I make t subject there. I'm going to have y minus 1. Of course, divided by 1, I still get the same. Then z plus 2. So this will be z plus 2, then divided by negative what? Negative 3, like that. So this here becomes my symmetric equation. Okay, so this is how you solve this question on this one. So right, so if you're new, remember to hit the subscribe button to receive more notifications and for more videos. I see you in the next one.